bloop. Now, the very last time we're going to see each other because this is it. And then y'all are going to take the test either today or tomorrow or Friday, technically. You have the ability for Friday, but it would be really cool if you did it earlier. No, okay, fine. Okay. That's fine. That's no problem. So, show me what you want. Tell me where you want to go. Or are we starting in 16 or something? I can't remember. Everything. Was that terrible? Okay. It'll be fine. It'll be fine. So line integrals, basic, very basic line integrals. Are y'all okay? Like ds means magnitude of r prime, and then you just start converting all these. Did you want me to do one? Oh, okay. Did you want me to do this one or a harder one? The hardest one? This one? Oh, I was gonna say I think three was be the hardest one because you have to make your points rather than the t given to you. Okay, let's do it then. I think it's the easiest one. But if you say so, I'm here for you. Kabloop. Here we go. Basic line integrals. So I need an r that travels from that point to the other one. So literally terminal minus initial. And so I'm going to start at, so if this is terminal, that's initial. So I'm going to start at the 1. And then I'm going to go to 2. So 2 minus 1. And then put a t next to it. Have a 1. And then I have a 4 minus 1. T next to it. Then I got a negative 1. And then terminal minus initial. Wouldn't that be like a 2 negatives make a positive, basically? Am I correct there? I think so. So 1 plus t, 1 plus 3t, and then negative 1 plus 2t. Sound effects included for the last time. Isn't that awesome? Derivative? You aren't saying anything. Has it just like stunned you suddenly? Like, oh no, this is the end. 16 was pain. That's it. Yeah? Didn't I extend 16? You did. Oh, okay. Yeah. Great. So y'all haven't done this yet. You're waiting to. Good. Huh? It doesn't technically, but yeah, terminal minus initial. I'm going to go, this is my initial, that's my terminal. Oh, from this to that. Oh no, I'm stunned. Okay, hold on. I have to literally start over because you're right. From to, it's not just 2 points and I pick whatever direction. Thank you for that. Negative. Yeah, it would be negative. Change it to a positive. But yeah, I feel so bad now. Okay, so my initial, and then I've got terminal minus initial. I was looking to have like more positive answers, but apparently that's not the right thing. 4, and then I've got 1 minus 4, and then I've got 1, and I've got negative 1 minus 1. I ran out of room. T. That's so bad. Anyways, let's do that. Simplify. Okay, cool. Oh, no. Okay, this guy. So y'all were quiet because I was messing up? See how everything's negative, though? That's why I was like, ew. But you're right. I mean, you're right. You're right. Bless you. So this is my x, this is my y, this is my z. And then I need to put them into my integral. So then I got x, 2 minus t, plus y, 4 minus 3t, plus z, 1 minus 2t. And then square root of my derivative. So 1 squared, 3 squared, 2 squared, dt. Combine like terms. So I've got -6. Oh. You're right though, Desmos. But yeah. I'm gonna simplify a tiny bit. Is this gonna be a 22? So I got 9 and 4 and 1. That's 5, 9, 14. Oh, okay. And I'm going from 0 to 1, obviously. Obviously. Okay. And so -6t plus 7 times the square root of 14, which is going to mess up our plans. Oh, it's 4 square root of 14. And you said 2 square root of 28? Or I have no clue. I will. And you want me to submit it immediately?
Well, no, I was thinking, look at my answer to Desmos, see if they both have the same value, but that works too.
I mean, unless I simplified something wrong. I'm willing to. Oh, no. Oh, you want me to plug in yours?
Yeah, Desmos, see if the values are the same. Because I'm curious.
So 4 square root of 14, and yours was 3.
Square root 22.
Close, but that's a 0.
Yeah.
Sorry.
No, that's fine. When I was trying to do research history, it's like, yeah, because your initial, you just subtract it by the terminal as t. Yeah. So, you would have your initial, so it would be 2, and then you go to 1, so you'd minus t, and then, stuff like that.
You were trying to just. Okay.
Yeah.
This is being recorded, so I can't say.
If you're trying to say I'm just brute forcing it, I totally agree. I just couldn't figure it out.
Oh, I was going. It starts with a C. It ends with a T. Okay, moving on. No, it's not an accusation. I'm just playing. You're wanting to chat about it. I'm joking. Google AI. Okay. No, I wasn't going down that road either. I was actually just going to say you're cheating, but whatever. I'm sorry. I meant no way. No, you're good. Are you good though? Are you good with what we did? Yeah. Okay, good. So line integrals. It's a little long sometimes, but in the end, the method is very straightforward. ds. What does that mean? Magnitude of v dt. Just and replace as you go. Yeah, basic line integral / something else, which we're going to see up here. Like this is part of that for sure. This is part of the same pool. So there's only 5 questions from 16. Basic line integral / work. You could see, isn't this the same thing? Integral FDR, essentially. Go ahead. Yeah. You want me to?
For R of t, does that mean x equals b, y equals t squared?
Yes. Did you want me to do that? Yeah, I could do it. I can actually do it all at once in Desmos because it's pretty straightforward. At least I think so. Let me do. Oh, I need a little bit of room for my big integral here. Shrimp. Okay, here we go. I think I could put it all in at once. So integral 0 to 1, obviously. And so my f is, it's f. It's FDR, dot. I have to dot product it. Okay, hold on. No. I can't do it all at once. I have to do a little bit by hand. Sorry to disappoint. Okay. So yeah, it's 4xy times. I would have to do my derivative squared. Okay, let's pause, start over. My r, t squared t. So my r prime, 1, 2t1. There's really no good way around this. There's no quick version, in my opinion. I just, maybe I'm wrong. So I have a vector 4 times x times y, 2 times y, negative 3 y. Hi there. Hello. Sure. Hi. Did y'all just take the final? Okay. How'd you do? Congratulations. Hi and bye. I'm being recorded right now. You're on YouTube. Oh, yeah. What's up? Not pre-Cal. I'm actually teaching Cal 1 in the fall, though. I don't know if that's a thing for y'all. Sorry. See you later. It's good to see ya. Negative 3t squared. T, thank you. You're keeping me back on track here. Yeah, don't let other people distract you, Chad. No way. And then we got 1, 2t, and 1. I'm going to dot product these things, and then we're going to integrate. So 0 to 1 of, say it again, 4t cubed plus 4t cubed plus minus, what would that be? 3t cubed. That's it, dt, right? Because it's already taken care of the other thing. So we got 8 minus 3 is 5. Desmos. What's up?
How do we know when we need to take the magnitude versus just taking the r prime? Like,
This was okay. ds equals magnitude of v or magnitude of r prime dt.
so the line integrals, the scalar functions, it has the ds. Okay. Okay.
Oh, on the workbook.
So it's just when we see ds, that's when we have to take the.
Yes.
Okay, that makes a lot of
Yeah,
sense.
ds equals magnitude of v dt.
Okay.
Yes. This one doesn't have a ds. So this is just integral FDR, which, I mean, again, there's a formula, I'm sure, for it, but integral FDR is integral of f dot r prime dt, essentially. So it's kind of like built in a dt.
That makes a lot of sense. Thank you.
Cool. But yes, I like formula-wise, ds equals magnitude of v dt. Like copy paste every time. Cool.
Definitely gonna be writing that
Oh
down.
yeah. Oh yeah. Definitely. Cool. So yeah, all these are going to be grouped together for sure. They're all very straightforward, singular. Even this guy. There. See, I know. Oh, FTDS. Whoa, whoa, whoa! We have a formula for that. It's integral FDR again. We already have the stuff for it. So don't, that's why you're going to have to write down all these crazy formulas, whatever you think is good for you. There's a lot. Yeah, and what you're doing in here is now you're finding what works for you. What is best for you in this particular case, So see, you have this integral whatever with the flow. Flow and flux, those kind of things are going to be important to you. But right here, integral FTDS is integral FDR. Same thing. Cool? Cool. And then you can even use this one if it comes out to be a little bit more handy and, flip-flop between them or whatever it is. Yes. Cool. Yay. It's a good study tool. So yeah, those are all the same. These are all grouped together. Work, same thing. Yeah. I can't remember if I put potential function as the next question or this one, because it is easy. I might have grouped it here just because I needed to reduce the questions down, or I might have put it in its own group. I can't remember, but potential function. So what we're doing is just 3 little integrals, aren't we? Yep.
At least for that one.
Yep.
Some of them give
some right. Some things are like this one has the same answer 3 times. So
Or there are other ones where you have to, like, this repeats itself, so you only include one of it.
yes,
This one has something special, so we slap that on.
yep, exactly. It is. It is. Yep. Whoa, whoa, whoa! It looks like they've done something very wrong here. There's no C. Oh, I know. So yeah, you do whatever you need to do by putting plus C or not, man. Well, I can go back and add points then. But
You already did.
oh, okay. Huh? Yeah, I do want to. I can't do that directly. So if you send me this question, then I can send it to them. At least I can look at it. So flux circulation again. I might have taken these and grouped them with the previous ones simply because flux circulation. I think that would be the flow. Oh yeah, right here. See how they're using the same words. So another way to say this is circulation, right there, and then the flux. So oh,
I believe it also goes for the same as work as well.
work is this one right here, right? And again, this is integral FDR, which is a little bit more familiar for us. This one's a little different, but I think there was an equivalent somewhere for that guy. Is it this guy, which is not too bad? I think it was something like that, but we're gonna see real quick, okay? But right, a couple names are important so that you know which one to do where. So this guy is the FDR, and this is the NDS thing. But I think in this case, the FNDS, I think N is just going to be the K value. Let's just verify. Can you don't mind for a second? Am I wrong? Say it again. I might be wrong. So they're saying this guy here is what they're wanting. Right. So I think that there's a quicker version back on the formulas. I could just do this M dy, so my nx. So m sub y minus nx, I believe. I don't know if it's dt or not, whatever. We'll figure that out. So this one here, my m in terms of y would be a -1 minus, what am I doing? Minus. And then my n in terms of x is another -1. Oh, oh yeah, I got a 0. Did I mix them? It says circulation. Did I do the wrong thing? No, that's the circulation. I didn't do that one. I did this one. I did this. Did I do something wrong? Well, we got 0 as one of the answers. It's great. 50% credit. I just cannot remember. See, even I need a little bit of practice on this stuff. Flux. Let me just go back, and maybe I'm just mistaken about where's my thing. Give me a second. Oh, here. Flux. This guy. Is there an equivalent that I was mistaken about? Go ahead. Do I have to do the magnitude thingy?
This equals that. I didn't know you had
Oh, that's Green's theorem, isn't it?
that's what it looks like.
Let's scroll down. Yeah, hold on. Yeah, let's go way ahead. Green's theorem. And I'm doing the NXMY thing, I guess. I'm not doing this one, but I'm really close to it. Oh, MY, there. This guy is this guy. Look, right here. There it is. Can I cheat and jump ahead? Use Green's theorem? So I'm saying, yeah, this is what we were looking at. This guy, actually just cut this guy out entirely for this problem. This is what we want. This is what we got. And so mx plus ny. Let's go back and do it. This will be way easy now. Yeah. Okay. So yeah, cut out this guy. I'm saying now double integral of mx plus ny dA. Oh yeah, this is way easier now. So this one in terms of x is a 3. This one in terms of n or y is a 4. So see how I've got 7 times the area, essentially? And so then my area is a square from 0 to 6, 0 to 6. So that's 6 squared, essentially. 6 times 6. So 7 times 36. I sure hope is 252. It's not 0. So this is the final exam. You have all the formulas. I would do what's easiest. But see how I need a list. Like flux equals this. Pick which one is easiest, right? Here, Green's theorem was easier. Oh my gosh. I just can't stand myself sometimes. Oh my gosh. Anyways. I was like, look, it's Green's theorem's easier. Come on, skip ahead. Okay. Me neither, man. Apparently I don't read nothing. No reading loud. So yeah. Green's theorem. Are we cool? Gosh. I could have made this a lot easier on myself by reading. Wow. Thanks. So Green's theorem is definitely in its own category. I think I did Green's, Stokes, divergence in their own little categories, I believe. I think. Yeah, I love it. Love this one. It says Green's theorem. Man. So y'all have learned now to read the problem carefully. Yeah, carefully.
Only if I have to.
So the two different versions, which again I have to keep pulling this up because that's perfect, bro. I love it. So flux is this mx ny, but circulation is this guy here. Okay, so nx my. So I got the flux is mx ny, and then my circulation is n my minus nx. Am I correct? Did I do that right? Y'all aren't telling me. Nx minus my. Nope, I was wrong. Nx minus my. Okay, we can do it now. So flux. Mx, this one in terms of x. That's it? Plus? No, yeah, in terms of x, I think it's fine there. I'm not doubting you. I was just wondering. Then here, 4. In terms of y, it's a -1. Thank you. See, collaborative tests, man. That's the way to go. Yep. So on the bottom is y equals x squared. On the top is y equals 0 to 1 of this thing, and then we'll get an answer here in a second. For circulation, and in terms of x, yeah, 4x plus 2y. Thank you. And same thing, we should just be able to get an answer now. So, off to Desmos land. And shroop. Cool. It's nice that we have Desmos to do it for us. Yes, indeed. I was looking up some technical documents, let's say, recently, because y'all know I do other things on the side, and someone was like using ChatGPT to get like answers to some kind of technical question or whatever, and he was like, something's not making sense. So we went to the forum, and they're like, well, where'd you get those? And like, he said, oh, I went to ChatGPT, whatever. And they're like, yeah, capital letters, never trust AI with your technical stuff. Like, and yeah, because they'll just make up things, it's just whatever. So yeah, but if we set it up, and all we're saying is compute, right? This is not AI, this is a calculator. Yeah, it's literally just computing for us. So it is different. We humans are always superior. Keep that in mind, engineers. Yes.
What was it for now?
Hi. Doing okay? Did you need me? Later? Are you going to go take the test? Okay. Did you need me though? Okay, hold on, I'm coming.
That's literally what I did. This is all 16. This is everything.
Do you mind if I take a photo of that?
Yeah, go for it. I literally have each section of like 60.1, 60.6.
Yeah, because I wanted to organize them the same way. I just don't.
Would you mind if I also take a photo? Awesome.
Yes,
a whole
paper
sheet
for
of
the
paper for the final.
That's been the case since Cal 2. I took a photo of each side just because I.
You know what? Just so that we don't take everybody past our, you can just send me that.
Alright.
Yeah, I was like, 16, I was like, 16, I'm like, what is going on? So I just wrote everything. I'll be honest, I somehow got an idea on the quiz and I really don't know how. Really? Yeah. I like had every like form of notes I had like all around me, all my homework's out. I'm like,
I was
I had my
doing the
notebook
same
from the previous sections. I had nothing to do with it as well.
I was like, my brain was hurting during that quiz. Oh my god.
I'm not gonna lie, I put water bottles in the fridge, turned on the fan. I'm like, okay, I'm starting to get overheat, just chugging down cold water, trying to keep myself cool.
I'm back. Did I do it right? Did I do it right? I can't tell with my math lab. Yay! I know, right? I-
30% real estate. I honestly think we need to make it bigger.
More cowbell.
Great touch formatting. So
Yeah.
is this basically the same thing, like your
Mhm.
region of integration is different?
Right. Yeah, you're doing top bottom. Yep.
Okay.
0 to 3.
But the app, where are you getting your app? They don't have. Oh, there. Yeah. I'm blind. Okay.
You good?
Yeah.
Okay, good.
Cool.
Sweet.
Because that one tripped me up a little bit, and I was like, I do this, but it's treat the bottom as the bottom.
Yep. Same thing here. All this stuff. So work. Oh no, that's a new word. No, it's not. I think it's just flux or whatever. So it's just we just got to know what they're talking about here. Same thing there. If it has anything like area that you can make an area. Ooh, find that. Oh, surface area. That's new. We have a formula for that.
I believe it's the square root derivative of x squared plus derivative of y squared plus 1.
Yeah. So yes, fx squared fy squared plus 1 dA essentially, dy dx or whatever. And so that's my surface area, but then I have my surface integral is g times that same thing. And so it's just the difference between a section. Like one is in one section, one's in the other section. They don't give you a g, you don't do it. They give you a g, you do it. Cool? No,
No,
not on that one.
That's the next section.
But I think I grouped them together. So like surface area, surface integral, because they were like basically the same essential topic here. This one? No, the other one. C equals 20? Did I skip it? Okay, hold on. Did I miss it? 26? Oh, it's changing the numbers. You're right. You like this one? I don't know. Do you want me to do it?
No, the one that we were just looking at, like z equals 20, then it's an equation that includes z. I would like to do 27 at some point.
Okay, I could do 27. Are you talking this guy? I'm so sorry. Okay, well then I'm gonna do 27. Brand new problem. Is this cool? It'll come back around. The area of the surface area, top one right here, this guy. So this is all telling me what my area is going to be, but this one here is going to be the F, essentially. I need to move the Z over and divide by 2. So I've got Z is equal to x squared minus 2y all over 2. And that's going to be my F. So then I need to find my Fx. Thank you for that confirmation. It's like armchair quarterback. You know what I mean? Just like, oh yeah, you got it. Pass the ball. Pass the ball. You did good on that play. Good job. Yeah. dy dx. So we got 1, we got a 2 basically. Double integral of x squared plus 2. Now I got to say that's an ugly little guy there. Good thing we don't have to do it. So we're going from, oh, actually it's not going to be that bad because of this guy. He's going to make it easy on us. Yes. Well, it would be a U sub if I cared. Yeah. Plug in the 3, I would get a 9, I believe. So 0 to 9. Am I correct? Because x equals 3, plugging it in.
Wait, but wouldn't that give you a
Oh, y is 9. My bad.
0 to 3 in this case?
Would you give me credit?
Absolutely, Chad.
Really?
Yeah, you put up with me all semester.
Gosh. You know what? I have. No, I'm playing. Where's my Desmos when I want it most? Desmos, where are you? Did I get rid of him? Is this my Des? Oh, okay. All right. Yes. You're right. I should actually graph what that area looks like, so I feel. Oh. But the answers with square roots and stuff. So I really do think we have to do it by hand, unfortunately. Didn't you say that like under your breath, Lee? No, you didn't? Okay, because it's good though. It's good. X squared plus 2 dy dx. Okay, so then I basically just toss the 3x in here. And yeah, I do have to do u sub. I'm actually asking you to do an integral by hand. So because I'm integrating, I'm to divide by that. So I essentially get 3/2. And then I'm going to have this x squared plus 2 to the 3/2. And then I'm going to multiply the whole thing by 2/3 from 0 to 3. These guys cancel, plugging in a 3 and plugging in the 0. Don't forget that, calculus 3 people. Looking at y'all. We got 11 to the 3/2, and then we have 2 to the 3/2.
I believe it doesn't accept that format, though. I think you have to do it like the way they have it, but
Bah.
actually, I'm pretty sure it does. Oh, it does? I wish I would have known that. Just make sure. Yeah. All the fun stuff you repeat at this semester.
Do you know if there's any questions that's gonna make you convert it to like R, U, and B?
Oh, converting into like cylinder or polar.
Yes.
Yeah.
The RU cross RV?
Yeah.
Yeah, there will be that. Yep.
We do one of those.
Yes. Sure. Good with this, though? I'm going to leave it up. Ryan's still writing stuff down. Oh, you're done? Okay, cool. If you find your little Z equals 20 again, tell me. but otherwise,
So with that last prompt that you just, no, that one, yeah. With this one, you just treat the y and z. Like, how would you solve this
I-
one properly?
because it does seem like X is the one that's kind of the odd man out. I probably would use this as my F. Yeah, in DZDY, exactly. Because you can see the area is very simple. You're just going to do like 2 circles essentially.
Yeah, because I rated that one on the practice quiz and I was doing some research and they said, oh, just treat it as like y and z, or
Yeah.
just like y and x, and then you put it in polar form.
Yeah, I would recommend that.
Okay.
Yeah, that's definitely better. I don't know if I had an LN on there, but anyways. Same stuff, same stuff. Yeah, that one's an easy one. Something about that ellipse. It's just like you multiply and it's done. I'm looking for something more. Oh, the G. There it is. See how they give you a G? But everything else is the same. Everything else is the same from your surface integral stuff. Oh, gosh, man. You remember this, right? You remember this one? Compared to this one? Yeah? Do you know? Multiply by 2. Top and bottom. Oh, man, how annoying, huh? I know, how annoying. And then all of a sudden, this one, you get this one, he's just, it's fine, you're good. No problem. Don't worry about it. Again, we've done all that. I'm not worried too much about it. I want to do that UV thing now. RU cross RV. Think. Give me a second to think about this. I think that F is the G that we're talking about. And so then you would just say Z equals this stuff. It would be the same as all the others. I don't worry about that one. Is that correct? It's not a worry one? You're good? Okay. I figure that's fine. H, although it looks crazy, it's still, yet again, same thing. You put that one up front, and then you do the same surface integral, surface area stuff, right? So take your derivatives, square root, Desmos. Same thing here. First octant. Watch out for that guy, right? Oh, this one here? This guy. For the Z. If you want that, that's the technical way to do it if you were not having me as your teacher. Though, actually, I do like technicals, so I don't know. Yeah, that's the true way to do it. But again, G even is not exactly what we're thinking, because you got x plus y plus, and what is Z equal to? It's 2 minus 2x minus 2y, and then you start with your derivative stuff, right? So again, you're saying that Z is equal to this stuff. And so then my derivatives would be 2 squared, include the 1, dA, essentially. Right, that 1 is the derivative of this guy. What's your derivative of this? Is just a 1, right? Well, negative 1, and then you square it will be a positive 1. Now are you happy? Yes, exactly. Eliminate your Z, divide everything by 2, and so you can see x plus y equals 1, and then you can reduce the y down, solve for x as a 1. Exactly. Because it's a surface, I would be very... no, I wouldn't do that. It would give you more than what you want. You want a surface is definitely 2 integrals. Yes. I think I made that mistake one time somewhere else. So, putting this all together, you can see that we got things mushing together here. Minus an x minus a y. And then this guy that's... What?
Because they would be 2 squared is 4 plus 2 squared, which is also 4. That would be 8 plus 1 is 9. So square root of 9 is 3.
Oh, it's a 9. I was doing... Why am I doing 5? Thank you. Square root of 9. 3. Got it. Yes. Perfect. So 3 times all this stuff. Desmos time.
I've been up too early, man.
What time do you normally go to bed?
Yesterday I went to bed at around 10:30, but my first class this morning was at 7:30.
What class is at 7:30?
My history.
Oh. So there's like me and a history guy that show up here for 7:30 classes? Great. Thanks. Is the answer just 2? Oh, okay, good. Good with this? A small tidbit. Just yesterday, the boss told me that I am going to teach Calculus 1 for the first time in years in the fall. Yeah, lecture at 9 o'clock in this class. Yeah, I guess.
What I'm hearing is we're just gonna sign up for your class just for that.
It'll be fun. Y'all would pass through it, no problem. Like the first chapter is limits. What do you do with a limit? Plug it in. Oh man, I can't say that.
I can always go back and try to get an A in Cal 1, you know?
If you want to, I would be happy to have you.
I was be asking, when do we take derivatives and integrals? Can I do that anyways? What is it?
No, we're calling out answers before you even reason the question.
I think that this one is going to be that RU cross RV thing.
This one wants you to switch it also in polar form as well.
Right, the polar form is that RU RV stuff. It kind of like makes itself that, I think. So real quick, what I want to do is go back to my formulas for this.
I've actually done that problem so many times I haven't memorized how you solve it.
See, they're trying to hint at it, but yeah, did they say flux? Oh, where's my thing? They said flux, and they got this guy here. I just have a feeling like this one is this guy here.
It is when I worked it out. That was one that how I solved it ever since I got right.
So right, so you could get it totally wrong, and that's I'll just add points. But let's go through and do it. So, is this you want to do this one? Okay. One yes means a yes. I believe the formula for this will be the F dot, and that's the RU cross RV stuff. DU DV. Is that correct? It's not the oh, it's just it's this guy. Thank you. All right, cool. So we got this guy. Oh, and plus and minus because I know I'm going to get it wrong. So what do they mean by this? And you could see that we're wanting to do polar mode, and so I'm going to force U is equal to R and V is equal to theta. And this is wrong. This is wrong, but it'll work. Just that you're going to get it wrong. So whatever. So R, in terms of R, essentially, it's like R, like path, but my derivative of this thing. So we have to define what R is equal to begin with. Give me a second here. My normal path for polar is R cosine theta, R sine theta. And then this one is just, oh, it's a cone. So you look at it, this is R, so it's 9R. Again, this is my X, Y, and Z path. So then when I do R sub R, then I'm going to take some derivatives. Just 9. Uh-huh. Oh, I know that. I'm purposely fighting the system here.
You know what, Chad? I respect it.
Really?
Yes. Exactly.
It's an easy way to get speeding tickets too. I'm just not following the law, okay? We've done this before, and we can do this the easy way or the hard way. Essentially, I believe it ends up being negative r cosine theta, negative r sine theta, and then negative r. Yes.
The thing is the r negative r cosine and negative r sine, those are supposed to be the sine.
9. There are 9s in there, huh?
Yes.
Okay, good. Thank you. Thank you. Thank you. This is something you can write down because it's something that we're gonna do. You're gonna see it if you're gonna do it. It's already done. You know what I mean? Yeah. So not 9, but just that 9. That's not a 9. That's an A. It just has a really long tail. Not a 9. Not. It's an A. So with that formula in mind, I should be able to. Oh, I did the cross product, so now I can dot them and be done with this thing essentially.
To find your r, you have to plug in the z into the 0 is less than or equal to, and then you divide both sides by 9 to give you r equals 0 and r equals 1.
Okay, hold on.
Okay.
Time out for a second. Remember with that skill we were talking about, right?
Oh, yes, right, don't make sense.
Because, well, I mean, I'm focused on math, and you're telling me, and I'm like, sure.
Oh, that makes so much more sense.
Yeah. I'm not giving you my. If I'm not looking at you and you're starting to talk math to me, just forget it, bro.
You're typical what I'm talking about. I'm looking like at the board. Yeah, my bad. I'm sorry, Chad.
No, you're good, man. You're good. I'm the one I should be paying more attention to you.
No, well, I shouldn't be talking when you're not paying attention to me.
We can go back and forth on this all day. So, x times y, 0, and then I'm running out of room. Oh, it doesn't matter because this is just 2 times 9r. No. I messed up. I was using the wrong place. Yeah, it's just the r squared, and this here is the 9r. Okay. So let me just real quick. 3r squared cosine sine 0, and then negative 18r. Okay, so there's my f. This is my n d sigma blah blah. So here we go. Double integral. It's double integral of this dot that. So this thing times this thing, we got a negative 27r cubed cosine squared sine, put some thetas in there, I guess, whatever, plus sine 0 plus sine, and then these two guys make a negative 18r squared dr d theta. There's no required r. It's already been taken care of. And if I'm going for my r, I should be going 0 to 1 because c 0 to 9, and so this is 9 times r, so r must be 0 to 1, and then 0 to, of course. Check it out and get the answer, hopefully here. But because this RU/RV stuff is always very similar, you could write down some of those formulas to make it faster, because you don't want to sit there all day doing a cross product and then get it wrong. Say it again. Sure. Yeah, that sounds great. Yeah, I'll give you credit. You always do what I don't. Yeah, what it wants every time is to do u is equal to theta and v is equal to r. Now, exactly why that is, I am not sure, because the formula does say plus or minus. It's like that one without the c in it. Why does it have no plus c in there? Yeah.
Right, like plus or minus any final answer. Like type in one or the other. Just go.
Well,
It's
well, sure. Or you could just always do what I don't. So, and then it'll be fine. So if you ever get a negative and do it Chad's way, just do it a positive.
Outward flux.
Where'd you see that?
I remember learning about physics, and then I just
In physics. It's somewhere deep down in some textbooky thing.
Well, also which conjunction to that conclusion too, since we know that z is either equal to or greater than 0, that it would have to be something on the positive side rather than it can be on the negative.
But my f has a negative for the z component here.
Right. Well, I mean, like your answer overall, like that could that be a hint towards it, or is that?
No, just do that.
Okay.
outward is positive, inward is negative.
Okay, there it is. Wow, that's interesting. Does it say outward though? Oh, it does say outward right there. Look at that.
You just have to read it.
Oh, that reading stuff again.
Is there something that like stands out in the problem that tells you you need to do the
Like that formula instead of the other ones?
Yeah, my biggest problem is like you just have so many formulas. It's
Yes.
just not know which one
So
stands out.
look at this guy, right? We're looking at flux, and it's got this formula here. And so I have that one written down with a lot of equals, equals, equals. So let's go back through all my formulas that include that one. Oh yeah, definitely. So flux. I'm looking for flux formulas. There's a flux formula. So this equals this so far. They're like literally I'm gonna have my big list, right? But this is not the same as FDR, okay? So we got flux right there. I'm looking for other flux formulas. Let's go backwards a little bit. Surface area. I don't see any flux formulas there. Again, I'm just going to have a big list. There's a flux formula. So this is all on the same thing. So this is also this guy is also this guy. So far, so good. But let's go back to the thing here. Do I have an m dy and an n dx, and then I can do dy dx? Perhaps. But then again, this one has only a 3D. This is not a 2D. See, so that's already scaring me. It's making me feel like this is inadequate. Feeling me on that? Could you make this into a 2D? I mean, it kind of looks like it could be. Right? Like you replace your Y with a Z and kind of roll with it like that? Maybe. I haven't done that. But then I would be very scared still. So far, you feeling me on that? Okay, so those are kind of iffy on that one. Okay, looking around, we're looking for flux. Flux? Oh, that's not an integral. Sorry. Keep going. Here's my big list of FDR, but I don't have. That's not my same list. I'm not looking for that guy. Let's keep cruising. And flux. Oh, didn't help me much. Here's another one that doesn't help me much. Already saw that one. That's not us right there. That's not us. Still not the same one. And so I'm kind of left. That was about it. I think at the end we have more flux. Oh, here's another flux. Would you rather do this formula right here? Can you do divergence theorem with this? Find the volume? Perhaps. Perhaps. That's up to you. I haven't tried it. If you want to. If you have the time. Yeah. Cool though? So yeah, that's another legit formula, and Stokes has got his own style of things too. So we're looking for not that one, not that one. Nope. Guess Stokes didn't have it. Okay, so there you go. Yeah, back to this guy. You're stoked about Stokes? Anyways, does it make sense? I have about 4 of them for that flux formula, and this one here just I remember seeing this from the homework, and I have to do my R and my theta and blah blah blah. Good thing I wrote that one down.
So you could always say U equal to R and B equal to theta,
Yeah,
like regardless of what the problem says.
sure. A lot of times I also do X and Y. I'll do this is u is x and v is y. Right, rectangular. Mm-hmm. Yep. Go ahead.
This is a weird little kind of thing. So with that problem specifically, you have to do like for the cross product, you have to have data on top and then R on the bottom. Would that have some sort of relationship with like how you map out points with Polar? How you'd have your R and then data?
Maybe.
Maybe.
But why would it come second then? See, R in my mind comes first.
Right. That's actually
I know. There's
counterclockwise chat. There we go.
sure. So yet again, planes, this and that. There's your outward part again. I don't know if I would go polar on this one because we got these guys. No, that would be fine. Oh, well, heck.
You know what?
It-
I'm hearing just partial credit. Just partial credit.
Yeah, just partial credit, man.
Exactly.
I think this one, because rectangular surface in the K direction, it is so easy just to do 0, 0, 1, and then you're done with that dot product and you're out of there. This one's a super easy problem comparison because of that. But you have to know it, you know what I mean? Same thing there. I would say y, so u equals x and v equals y, if I had to do that. Curl, that's a whole new thing. So I don't, you know, I don't think I actually have this on the exam, honestly. Did you see one of these on your exam? No?
I don't think any of us have taken the exam.
No. Oh, because this is on the final only. My bad.
Yeah.
If I did curl, then I did curl with something else, but yeah, see, I don't think I put curl in there because Stokes' theorem kind of takes care of that. So yeah, Stokes definitely has his own question, and then Divergence has his own question. So I think it's roughly 5 questions there. Do you want me to do one or two? Oh, okay. Tell me which one. This one? Another one? Okay. All of them. All of them. So, good thing I wrote down all my formulas for this, right? So, Stokes is this guy. So, grad cross F. Oh, look how he's converting it to the NDS thing. And so then we would be scared. So I actually like some of this better in this case. I don't have that. I have 3. Okay. Well, we're gonna just figure that out then. Let's find the curl. Let's start integrating and hope for the best. This is why when you do your work, you do it. You know, you write it down. It looks pretty. Oh, look! I saw your direction. Anyways, so integral FDR. Oh, could I just take that literally? I mean, I have my F, and I can make an R, and then it's done, isn't it? In a way here. I'm wanting to know X, Y, and Z, essentially. Like my path. But this path here... ellipse, XY plane, counterclockwise. I don't know. I'm not going to trust it. I'm not going to trust it. Find the curl. Find the curl. Find the curl. Back up. Back up. Okay. Here we go. So del X, del X, del Y, del Z, cross, and then this stuff here. X squared, 5x, z squared. Always start with a 0. In terms of x, we got a 5k. In terms of x, we get a 0. In terms of y, we get a 0, and a 0. In terms of z, we get a 0. In terms of z, we get a 0, and we get a 0. Oh my goodness. Yay! That's nice. And then I'm supposed to dot that with the NDS stuff, essentially. D sigma, I don't know, something like that. But we've already done this kind of thing before. So give me a second to think about this. It's like I've turned this into a flux problem, essentially. Couldn't we use the RU/RV thing? Or maybe I should use something else? Should I go back into my formulas again? Mm-hmm. You know what? Honestly, can you hang out with me for a second? Watch this. I have an idea. I had this idea earlier. What if I did this? If I did this as my RU cross RV, but I chose U equals X and V equals Y, I believe what happens is everything cancels out because it's just an ellipse. Go ahead. Mm-hmm. Mm-hmm.
That n is the normal vector of the ellipse, which is 1k. Because
Right.
the ellipse is on the xy plane,
Exactly.
so it's always 1k.
Exactly. Yep. I'm feeling you. So we got 5 dA, 5 times my area of this thing, and so I'm looking for the area of my ellipse, and that's just pi AB, and so I got pi times 5 times 3, and then I've got all this times 5, so 25. Hold on, I messed up. Is it not just 1? Maybe I have to divide by something? It's a scalar thing, isn't it? Right. Oh, because there's a 4 right here. Oh my goodness. All of that was me just. Okay. So, timeout. Since algebra, since pre-cal, whenever you have big numbers in the top and anything over here, it doesn't really matter. They always just go down to each other. So this has a 25 and this has a 9. Always, right? Always. Except today. Bad Chad for assuming. I know. But another thing, I'm realizing like my answer's way off, and hopefully I got points for that. So I'm going to divide everything by 4. So I've got x squared is equal to 4 over 25. And then I got y squared is equal to 4 over 9. Now, interesting stuff here, because if I want it squared, yes, and then this guy here. So there is my A and my B. So I got 5 times pi times 2/5, 2/3. The 5s cancel, 4 over 3. We did it. If I only took a second longer to do it correctly, instead of assuming. So this is my answer down here, right? 5 times the area. Well, I don't want to try to find the area of an ellipse without just a formula. So I just basically, I wanted this formula, the pi AB, but I wasn't thinking properly the first time. Cool. Okay, we did it. Yay, the easy one. And we're 10 minutes past. Yes. Yeah, Green, Stokes, divergence, 1, 1, and 1. And then simple line integral. And then I think I have the surface area, surface integral, essentially. So there's your 5, I think. I think that's about it. Cool? Okay. I'm running over time, and I actually do have a meeting in a little bit. I don't mind keep going for a few minutes, though. Up to you. Yes? Yes. What's up? You want to go back?
So, do we need to do the integral at all?
No. No, it's just 5 times the area.
5 times the area, so we just find the area.
Yeah, find the area. That was it?
The area of the ellipse.
Yeah. Oh, it's already changed.
Yeah.
But yes, it's just 5 times the area. This is my area formula for an ellipse. 0. That's a good guess. Yeah, I know. That one looks crazy. I don't think I have this one on there, just because that one's nuts.
I'm so glad you did actually, because I only did a couple of them off the practice quiz before taking the quiz, and I'm so glad you hit that on the quiz.
Yeah, I'm pretty sure I removed it from the quiz. I don't know if I even have this one on there, but we can do it if you want to. Can't remember. This guy? You got to tell me. I know, like, okay, most of this stuff I have the notes for. I've already posted, and I did the video for it, right? So, but, I mean, I could try again. You tell me. Or I can go to Divergence and point out a couple things. Divergence. So, Stokes. Super stoked about Stokes. That one's not on there. Mm-hmm. Oh, let's go back. Yeah, that's the grad cross F. Yeah. So this is your F. It's like a very simple thing because you got 0, 2x, 0. So like when you grad it, grad cross F, it's going to be like one number somewhere or 2. Well, it's just a grad operator. It's a grad operator. Yeah, this is the same thing. You got it. This is Stokes because of this chunk right here. And yeah, and because hemisphere and all the normal vectors pointed away from the origin, I think that one's, there's a special thing that I did for that. I can't remember, but I definitely have that on the video / notes that I posted. Divergence theorem. So it says divergence. I find it's happy days because you're just doing triple integral of volume essentially, right? But I could do this one if you want me to, or the next one. Yeah, let's do it. Okay. So here we go. Triple integral, and it's grad dot f dv. That's my divergence theorem. So I need to still dot product these things. There's my f. So if I'm going to dot it, it's kind of weird. It's like I'm taking the derivative of each one individually. So I'm going to say this derivative in terms of x, 0. This one in terms of y, 3x. And then this one in terms of z. And so then triple integral of that thing dv. See, meeting time. It's okay, I got time. Solid cylinder. This guy between z and this thing. Ooh. So 0's on the bottom and this thing's on the top? Yeah. I guess it is polar here. Let's just understand what's going on here. It's a cylinder, but then it's a parabola kind of like on the inside here. You're doing it's a dog bowl. It's a dog bowl. Like for your dog. So or a cup, I guess. A little cup, glass cup, shot glass. Yeah. Exactly. It's being held. Yeah. It's a holder for an egg. Yeah. I like that. It's way better than dog water. So anyways, so I'm gonna triple integral my z. I have a top and a bottom. So that's an r squared technically. My r 0 to 2, and then 0 to 2 pi of 3r cosine theta minus 2 r dz dr d theta. That's cylindrical, or I say polar, essentially. Desmos, for sure. I really like divergence theorem the most because it's happy times where it's like home. Oh, I'm just finding a triple integral for my volume. Oh no, what's wrong? Oh, okay. There we go. We did it. Dog water. It's beautiful. Yeah, there we go. Oh, outward flux negative. Okay. Is this okay? Divergence theorem? I like it the most. It's my favorite. So, I am over time. I do have to go to do the meeting thingy. But are we good with this generally? So we're not showing up tomorrow. Okay, y'all can show up tomorrow. I'm not doing class tomorrow, correct? Okay, good. Cool. I'm gonna stop the recording. Bye.